Hello students, today we will be starting a new dimension in our transportation engineering lab. So far we have seen some experiments regarding aggregates. As you know, in last few classes from the beginning we have discussed about aggregates so far. So aggregates which are used in highway engineering especially, just because these aggregates will provide the strength of the pavement, whether it is rigid pavement or whether it is flexible pavement, it doesn't matter. So in both these two cases, two type of pavements, aggregates are very important thing, as you know. So now after aggregates, there are many experiments regarding aggregates, as we have said in the very beginning of this sessional course, but all of those experiments will not be covering here. Just representative some important tests we have covered so far. Today we will be moving towards a new phenomenon, new topic regarding transportation engineering, which is very common and the most important one, I think, in perspective of transportation engineering or highway engineering, especially the pavement engineering, if I say. So pavement, in pavement, the most important topic, if we can expect, which is bitumen. This is the most abundantly used term in transportation engineering. If we are transportation engineer, we are working with highway, we are working with pavement, then this term is a must, which is bitumen, as you know. So in this regard, we will be conducting some bituminous materials experiment in our course, particularly in this course. So we will be starting it here. So far we have completed 6 experiments regarding aggregates. So today we will be starting experiment number 7. Experiment number 7. So while discussing about bituminous pavement, we need to discuss about some properties of bitumen. Before that, I would like to ask you a question. Do you know what is the difference between asphalt? What is the difference between asphalt and bitumen? I think many of you have already played asphalt hot pursuit. You have at least known about this name, asphalt hot pursuit, very renowned, well-known game. Some of our colleagues, some of our friends, even I have seen whenever we are in student life, were addicted in this type of game. This type of online games are there. So asphalt hot pursuit. So that asphalt, what is asphalt and what is bitumen? What is the basic difference between these two? So if I ask you, can you give me any explanation, any particular difference between these two? Well, if I want to mention the difference between these two, I can say many of them. Many of differences can be mentioned in this regard, but I will not be going too complex for this. Basically, this asphalt and this bitumen is the similar thing, as you know. What we call asphalt, that is bitumen in from common point of view, but from engineering definition, from engineering point of view, we can differentiate these two. So in particular, if we say USA, American standard, USA, if I say A, they are used to call this particular material as asphalt, as they start from A and also they are preferring A. And the British one, as we know, they are very likely to name this thing as bitumen, as they start from B. Hopefully that is my explanation, but nothing like that. This is just for fun, but you can remember it like this. But these two things are all the same. from common point of view, but from engineering point of view, if we classify these two things, we can classify this as different with respect to the different factors, you know. So if I want to differentiate those, I'm not going to differentiate those things. You will be learning these things in details in your theory courses, but in general you need to know this. These two things are basically the same thing, almost the similar thing, just difference is one thing whatever I am naming it as number plate. Say for example, this is your number plate of your vehicle, and another I'm saying this is license plate of your vehicle. So the difference is like this, nothing else. So also these two are differences these differences are seen in between American and British practice as well. Also you see in sieve analysis, as you can if you can remember that in sieve analysis there were two provisions. If you can remember that whenever the sieve analysis, the gradation curve, we wanted to draw one probable graph is this one. The convention is left to right. Another convention was there, which we can also draw this graph from there. So where the least value will start from this and it will going further like this. So these two are sieve analysis gradation curve, but these two are different just because these two are starting from two different sides. One is from left, one is from right. But why? Just because of these two are also differences made by USA and British. As you know, they are a dramatic collision from the beginning of this technology and all other aspects, as you know. So there are differences, but we are not going to focus on these things. But why I am mentioning this, you will be able to understand that experiment number 7 what we will be conducting, that is one property of bitumen. So one thing I need to mention you that yes, Americans, USA also calls bitumen in other aspects from their engineering point of view, but they as a whole say these things are bituminous materials as a whole, and asphalt they particularly divided. This is particularly asphalt among all bituminous materials. They somehow classify this thing. So however, to say about the properties of bitumen, there are different properties using which we will be studying, and based on those properties we will be judging those properties, whether those properties of our particular sample bitumen which we will be using in our highway, whether those criteria the criteria satisfies on criteria, all those criteria satisfy or not. That is our main concern whenever we are engineer, we are going to construct pavement in the roadway. So that's why therefore we need to know some of the properties of the bituminous materials, and in this regard whenever we are conducting tests in our transportation engineering sessional, we will be automatically introduced with some of the bituminous materials properties as we will be starting from today's class. So first of all, the experiment number 7, the name, that is the specific gravity. This is one important property of bituminous material which we need to know, and why we need to know we will be learning after this lecture ends. By the time we will be finishing this lecture, you will be able to understand, I think. The specific gravity of semi-solid bituminous materials, that is the term semi-solid bituminous materials. So this is the term of this experiment number 7 we are trying to conduct. We will be learning how to conduct it and what is the basics behind this today. So specific gravity, you are I think well acquainted with this terminology, the specific gravity. What is specific gravity? But before starting, I need to mention that we are following these experiments according to ASTO designation as well as the ASTM. So AASHTO. So this is ASTO. If I ask you, you should be able to give me answer. What is the full form of ASTO? I think you will be able to answer me. Please give me answer. What is ASTO? All of you should know this. ASTO, the full form is American Association of State Highway and Transportation Officials, as you know. So this basically indicates the American standard, as you know. So from the name, as we can know, this is American standard. So ASTO designation, so you can easily understand there is also some conflicts between Americans and British as well in these experiments as well. If you can remember the codes, the designations we have used in case of aggregates, if you can remember, you will be able to understand that in the aggregate test we have conducted all the tests according to British standard, as we have used British CEE. So BS standard was there, British standard was. So in this case we are using American standard. So basically these differences are there already, we are watching here, just because of what we Bangladesh authority are, especially actually the hybrid one, we are also using both of these two. We are, whereas we are following British standards for most of the aggregate test, and in case of bituminous test we are following the American standards. So this is something weird, but this is hybrid activities from our authority, we Bangladeshi people are. But this is also a matter of regret for us, just because we couldn't establish by this time any particular standard for Bangladesh. In particular Bangladesh, we are just copying from British standard and from ASTO American standards. So, but if you just focus on, if you look at India, our neighbor country, they have already established IS, India standard. If you can see, there are many experiments, explanation all over the internet. If you can search, you'll be finding there. But don't be confused with this thing. Whenever we are conducting any experiment, just make sure that which standard we are following, otherwise you may get confused. There are same experiments which can be conducted based on both standards, many standards, maybe IS standards, maybe American standards. So you may get confused if you do not focus on which standard we are following, we are conducting test. If you focus on one test, that may be IS standard which is uploaded in the internet, but whenever you are focusing on that and you are comparing this with our sessional, you might get confused and you might get wrong result and wrong interpretation, just because based on a particular standard some considerations, some basic assumptions are there. That's why if you do not maintain all other things according to that standard, just following the procedure will give you wrong results. So that's why the standard is an important thing we need to follow always. We need to focus on. So however, what I was speaking about, that this is the ASTO designation we will be mostly focusing on in case of bituminous materials. So this designation for this experiment is T22893. Also that is the same experiment can be designated in the ASTM standard as well. And I think I need not to mention what is the full form of ASTM, D70 to 76. So these two are the same standard for this particular experiment. So as early as possible we need to establish Bangladeshi standard, and for that our researchers in this country should be dedicating themselves in these studies. Otherwise, if we just following this standard, you can easily understand that these standards are mostly based on and focusing on their country's perspective, not the global perspective most of the time. So that will be likely to facilitate those countries. We will not be getting much benefit. We cannot expect to get much benefit from this designation. So we need to create our own standard. That should be our philosophy, not just copying pasting from other sources. That should not be our vision. However, so this is the designation of ASTRO and ASTM we are following for American standards for bituminous materials, as I have said. So what is our topic? The semi-solid bituminous materials. So what is semi-solid? What do you think? What is semi-solid? What is the definition of semi-solid? Can you give me answer if I ask you? In general, if I say semi-solid is the state in between solid and liquid, if you can understand. This is the state in between solid and liquid state, which indicates the highly viscous materials. Highly viscous materials, which is in case if you assume it as liquid, but it is not as liquid as it can be. It can flow like ordinary liquids like water. If I say it will not flow like that. So the flow will be interrupted just because of its high viscosity, and that's why we say this is semi-solid state. And this semi-solid bituminous materials example is the bitumen, the asphalt, which we always use in our highway construction. As if you can see, I think all of you have seen this bitumen which we use in our roadway construction, but many of you might not have any proper concept about this asphalt, the categorization of these bituminous materials. So in this experiment we are focusing on those semi-solid bituminous materials and specific gravity of those. So we need to know something about this. So we have some questions regarding bitumen. Okay, bitumen, I have just seen this is blacky particles, but I do not know much about this. What should be the properties? The first property we will be trying to discuss today, that is the specific gravity of bituminous materials. Many of you have just seen these bituminous materials, but you cannot expect whether it is heavy or whether it is lighter than water, or how does it weigh, and how much this weigh. If I ask you, you cannot give me satisfactory answer or reply if I ask you. So these experiments, all these sessionals will give us some clear overview outline on this bitumen. So bituminous is a sticky, black and highly viscous liquid, as I have said, or semi-solid form of actually the petroleum. So I think all of you are well introduced, well acquainted with this thing, the petroleum, organic material. Whenever we learn organic chemistry, we get introduced with this particular thing, that is the petroleum. So this is an organic product, as you know, and this is form of petroleum, and from petroleum actually we get different type of bituminous material. All products we get from this are the we can categorize it as different bituminous materials. The primary use of asphalt or bitumen, whatever we say, those use are in roadway construction. The main purpose is the roadway construction. This is the primary use of this asphalt. So where the uses of this, if we ask which type of role this bitumen or asphalt play, in the which type of role this bituminous materials plays in case of roadway construction, I will give the answer like it is actually the gluey or binding mix. It can be used as binder or gluey particles which will be mixing the aggregate particles with this asphalt. It will be used, say for example, these are aggregates to, and these are aggregates in the pavement. To make these aggregates in contact with each other and not getting off from this pavement in sudden manner, to keep it jointly together, these bituminous materials which we'll be using, the bituminous materials can be used in between this, which will be acting as binder, so that all the aggregates are stick together. Otherwise you will be watching that these aggregates will be dislocated from its original position, and that was the main problem in case of the former aggregate type of aggregates. If we give focus on the history of aggregates pavements, you will be learning that the main problem, one of the main problems of the previous aggregates, that those aggregates always stripped off or getting out of the original position from the pavement, just because of there was a problem regarding any binding material which will be able to bind all the aggregates together, so that the aggregate might exert the original strength of this whenever it will be coming in contact with what high pressure like wheel or all other weights. So that's why, to provide sufficient strength in a combined manner, this bituminous material will be acting as a binder for binding all those aggregates. So that is the main purpose of using these bituminous materials. So in addition to this roadway pavement, the bitumen has some other application as well, such as bituminous waterproofing products, including production of roofing felt and for sealing flat roofs, as if I give example. So there are some other applications as well of for this particular bituminous materials. So bituminous materials, as I have said, from USA they classify these things. So bituminous materials, if I give example of, for giving definition of bituminous materials, so they said that these bituminous materials includes tar and asphalts. So they basically say that this tar, asphalts, all are included in the bituminous materials, and this particular asphalt, which the British calls as bitumen, they are calling this as asphalt, and they are as a whole denoting all those types of materials as bituminous materials. And this asphalt, if we give example, you will be learning in details in theory, hopefully. So these asphalts can be either natural, or this can also be processed. They can also we say those as processed petroleum asphalt. So they can be processed from petroleum. How? I think you might have known about this process, the petroleum, from we can obtain how these asphalts can be obtained from processing as condensates in the processing of coal, so in processing of petroleum. But in case of tar can be also this can be also found by processing of petroleum, but this tar is not occurring in nature. If I say this tar, I think all of you are well acquainted with this tar are not occur in nature, rather it is also obtained from processing, such as processing of coal, petroleum, oil, shale, wood, or other organic materials, if I can say. And one particular thing I think you are well acquainted with, which is the word is pitch. are well used term in terms of Bangladesh. We say pitch in terms to indicate the petrol this asphalt, but with this pitch is actually formed when the tar is partially distilled. When the tar is partially distilled, I think you have known by this time about the distillation. So whenever the tar is distilled, then so that the volatile constituents have evaporated off from this tar, then only the pitch will be the remainder. This is called pitch actually. So there are some differences. I'm not going to focus all these things just because if I focus on these things I will not get enough time to describe about our experiments. Today these experiments we have many things to understand this in this experiment particularly. So this particularly we will be conducting this test. So remember one thing for your quiz and all other cases as well. For different experiments I may be giving you a question like what are the spatial apparatus. There are some ordinary apparatus we use for all types of experiments. Generally those are not focused on this particular question, but I am asking you about the spatial apparatus. So spatial apparatus for what? For all the experiments. If I ask you for different experiments, what are the spatial apparatus for this experiment, for that experiment, and for those all other experiments, you need to write down one by one listing just after the experiment name, experiment 1, that is AIB, then you will give the spatial apparatus name of this test. So in this case as well, for our this bituminous semi-solid bituminous material specific gravity test, our special apparatus for this experiment number 7, that is pycnometer, we will be using. So I think you might have been acquainted with this pycnometer by this time if you have conducted or learned about the soil mechanics lab. So if you are acquainted with this lab, you might be acquainted with this pycnometer by this time. If you are not, I think whenever you will be conducting this test regarding soil mechanics, you will be also acquainting with this pycnometer as well. This pycnometer is actually used for the determination of specific gravity of anything. So in this case we will be using this pycnometer for the determination of semi-solid bituminous materials. What is pycnometer? Pycnometer can be of different shapes. So in particular for this experiment 7, according to us to our ASTM designation, it says about two particular shape of pycnometer which should be used. I don't know whether we'll be using in actual practice in IoT whether we'll be using both of these two, but according to this standard we must be using these two type of pycnometer, and after using these pycnometers we must be comparing the result of this pycnometer. So pycnometer, one is the conical shape pycnometer and another is the cylindrical shape pycnometer. So this is actually the 2D representation of these two types of pycnometers. One is of conical shape and another one is of cylindrical shape of pycnometer, in which we will be conducting the test to determine the specific gravity of semi-solid bituminous materials. However, in this experiment we may use in both this type of or either of this one we can use. If we have both of these two apparatus, our two groups will be conducting, or if we have 4 groups, 2 of each will be using this one and 2 of those will be remaining 2 will be using this one for their experiments. And for specific gravity, one thing is very much important, and whenever we are talking about semi-solid bituminous material, that is mostly important, that is the temperature of the experiment. Temperature is mostly important. Temperature is mostly important in case of specific gravity, and that's why whenever even we are reporting reporting the result, we also need to mention the temperature which we have used for the determination of specific gravity. According to our this designation we have used as TM or ASTO, we will be conducting either of these two temperature, that is, one is called 25/25 degrees centigrade, that is 77/77 degrees centigrade, sorry, not centigrade, Fahrenheit, specific gravity at this temperature, or it can be of 15.6/15.6 degrees centigrade. In bracket we can also say this is 60/60 degree Fahrenheit. So either of these two temperatures can be used for the experiment. So if we use this one, whenever reporting it, we will be saying that we will be reporting like the specific gravity is this. In addition to that, we will be mentioning 25/25 degrees Celsius, in bracket 77/77 degree Fahrenheit. So, or if we use this one, we will be mentioning this one. Just because of what? Just because temperature, if the temperature varies for semi-solid bituminous materials, obviously the specific gravity will also vary with that temperature. That's why this temperature must be maintained in this experiment. That is, this temperature is very much temperature sensitive, and if you just differ the temperature beyond in this range, this particular value, then it might give you wrong indication about the result, and the people or the engineer who will be watching this report will also get the wrong information. As a result, your total pavement quality will be degraded, just because of you will be focusing on this report to get idea about different things, how to place it, how to place this bitumen, and all some other aspects are there, which decisions will be made based on this particular value. So specific gravity of these bituminous materials. So so far we have learned that this temperature maintenance is very important, and to maintain this temperature, and another apparatus we will need in this in this experiment, that is the water bath, where we will be always keeping the temperature of water at our desired temperature to maintain the temperature in our expected range, just because otherwise the water can keep the temperature as much time as we use or we want. Other than that, we cannot keep it in others any other. If we just keep our pygnometer in air, we cannot maintain the air temperature always as we are expecting. But in water bath, the facility, the opportunity for us is that we can keep or maintain the temperature according to our expectation of all of the time as we want. Just because we need to maintain this temperature not only for 10 minutes, not only for 5 minutes, not only for 15 minutes, we must be needing to keep this temperature for more than half an hour, more than 1 hour, if I say. So that's why this water bath is also another important thing to be used here. So water bath is something like this. A box will be there, that is called water bath, where there will be always which will be always filling up with water, and those water will be always maintaining the temperature as per our expectation. By some means we'll be giving heat and keeping the temperature of the water of either 25 degrees centigrade or 15.6 degrees centigrade according to our requirement, and that's why the water bath will be used here. Another thing I need to mention, that in pygnometer there will be in pygnometer, as I was talking about, the pygnometer that will have the stopper, the glass stopper, which will be fitting accurately within this pygnometer. If I say, the there will be a glass stopper which will be automatically fitting in this picnometer, and the bottom surface of this stopper will be concave in shape. Just because of what? Just because to remove the air void or air bubble. If I say this will be concave in shape, so that it will remove air bubbles through this, and that's why there will be also an opening. If I say, I am not going for further details of this picnometer, this stopper, there will be a hole within this, from where, if it is concave in shape, those entrapped air will be getting out from this using this particular hole. The entrapped air will be getting out after this one is filled up with water. So if any voids, air bubbles are entrapped within this, that those will be through the structure, the concave in shape that is feeding within this, the entrapped air will be going out with these holes. There are dimensions of this. I am not going to discuss about those things in details in there. Those are not very much important for us regarding this experiment, that's why. So obviously there are some specification regarding those. However, so this is picnometer. So for example, I have given the example of the conical shape picnometer in this case. However, so now we'll be starting the experiment, but before starting the experiment we need to prepare this bath. We have said this is the water bath. We need to prepare this water bath according to our requirement. The required temperature will have to be maintaining in this water bath. So in this water bath we will be maintaining the temperature and according to our requirement of this AST or this astro designation, we need to keep the temperature within this range. 0.1 degree centigrade deviation is allowed of the desired temperature. So if it is 25 degrees centigrade, then either 24.9 or 25.1 degrees centigrade is the maximum range which it can deviate from 25, but not more than that or not less than that is allowed for this case. So we need to maintain this, and if it is prepared, then we can use our picnometer there. So picnometer, if it is always kept in this water bath, so we can expect that obviously this temperature of water within this picnometer or the semi-solid bituminous material which will be placed within this particular concave shaped or the cylindrical shaped, whatever we will be using, those temperature within this picnometer will be automatically maintained and changed within up to 25 degrees Celsius, and for that we need to keep this within the water bath for a particular time. We will be discussing about this procedure one by one now. So first of all, before getting into that, I need to say we need also a balance for this experiment. So balance will have to be using. The balance has also a specification which is according to the astro requirement, we need to use M231 designation and class of B. There is a class for that particular balance should be used, and remember that in this particular experiment the balance should be able, and we will be getting the rounded 1 milligram value. In case of aggregates we have said about rounded gram value, but not in this case. In this case we'll be more sensitive about weighting this thing just because it is specific gravity. So that's why we will be taking rounded milligram value. So we'll be rounding this to 1 milligram, up to 1 milligram. This is our rounded value specification for this particular experiment. So balance should be able to take the weight up to this range of up to this particular precision, as you know. So we need to maintain the temperature, and obviously this water which will be used in this water bath, the requirement for this water bath, there will be the obviously we'll be using distilled water in this water bath as well. So distilled water will be using for filling up this water bath, and after that we will be using the picnometer inside this bath. So one by one we'll be starting now the procedure for this particular test. So first of all, what we will be doing, first of all, remember that we will have to take 4 weights in this particular experience. Take 4 different weights. So 4 different weights we'll need to take in this particular experiment. So A, B, C, D, which will be designating for these 4 weights. So thoroughly, first procedure will be, we need to thoroughly clean, dry and wet the picnometer. Then we will be wetting that particular weight of that particular picnometer. So after it is dried, thoroughly clean, then we will be wetting this up to 1 milligram precision, as I have said just earlier. So designate this mass as A. So the empty picnometer, dry picnometer, the weight of that picnometer will be designated as I have said, the designation will be A. So then what we'll be doing, then we will be filling up. There will be a mark like this up to which we need to fill the water. We not beyond that, just because the stopper, as we have said, will be fitting this picnometer up to this one. So that's why, as it will be filling up to this, so this mark we need to always target to fill the water with. So we'll be filling this picnometer with freshly distilled water, which is boiled also, boiled distilled water, deionized water, at the temperature, at test temperature, the temperature, say if we are using 25 degrees centigrade, then we'll be using 25 degrees centigrade water, and after that we will be placing the stopper on the picnometer to make this intact. And as we have said, there will be some a very small holes within this picnometer, this stopper. So if there are entrapped air or additional water, whatever you say, if there are something like that, then those air bubbles should not be given provision to kept within this picnometer. Rather, those will be getting outside from this picnometer in any case, in any how we will be taking all the air wires out from this picnometer. Then we will be allowing the picnometer to remain in the water. Water means what? Water bath, where we are water bath, as we have said earlier. So where we will be keeping this picnometer for at least 30 minutes, not less than 30 minutes, not less than 30 minutes. We will be keeping this picnometer filled up with water after removal of air from this picnometer. We'll be keeping this picnometer for at least 30 meters, as you know. So not less than 30 meters we will be keeping this picnometer in the water bath. And as we know that water bath is always, we are keeping in our expected test temperature, which will be 25 degrees centigrade or 15.6 degrees centigrade, whatever we are using. So we are ensuring that this, all the picnometer including water and everything will be maintaining that actual test temperature as we are using. So whenever 30 minutes is over and more than 30 minutes has gone, so we will be removing the picnometer, and immediately will be dry the top of the stopper, the top of the stopper top of the stopper. So just because there will be holes, there might be water coming out of it while maintaining the water, and as we have kept it in the water bath, not totally immersed in the bath but at least up to some height, so the surface, outer surface of the picnometer will be obviously wet as well, so as it was immersed in water. So whenever just remove, immediately you need to dry the top, as just because some water or vapor might be going out of it and will be storing on the upper surface, then you will be using just one stroke with a dry towel according to the specifications to make this surface dry. So you will make it dry with one stroke, and then quickly you will be drying the remaining outer portion, as we have said. So the remaining outer portion, will be also dried. This outer surface will be also dried using the towel, but the top surface will be dried immediately just once, and not giving much time, just because we need to keep the temperature not beyond not degrading for the best temperature. We have kept this in the water bath for sometimes more than 30 minutes. So we will be immediately then weighing this again up to nearest 1 milligram, and this next this weight will be denoted as C, which is the picnometer plus the weight of picnometer plus weight of the, you know what, picnometer plus weight of the water. So this is our weight B. So this is our weight B. Okay. So now what we need to do, that we need to again we'll be learning, we'll be interpreting why we are taking weight like this afterwards, when we will be describing the formula of this particular specific gravity determination. For this determination, we'll be interpreting why we are taking this. So then what we need to do, whenever we have completed taking the weight of B, now we need to there are some specific guidelines, so I'm not going to focus on all of these things. What we need to do after that is we need to use the bituminous materials we are expecting to be poured within this particular picnometer. After that, just for that, before pouring the semi-solid bituminous material within this picnometer, we need to again remove all those waters and make this picnometer dry before pouring the semi-solid bituminous materials. And one thing you need to know, that this semi-solid bituminous materials, why we are calling this semi-solid, you know by this time that just because this is semi-solid, this is viscous. But one thing you should know, that bitumen in normal temperature, as you know that this bitumen in normal temperature is not liquid, is not working as liquid as we are expecting. Rather, the bitumen in normal temperature, if I say the 25 degrees centigrade we are expecting, or 15.6 degrees centigrade, it is not as liquid or as we are thinking, just rather it will be acting as solid or rubber like material. So you cannot pour a particular shape like liquid within this. So for that, you know that, I think by this time you also know that for bitumen we need to raise the temperature. If we raise the temperature, then it will become fluid like particle, and the viscosity will become lowered, so that liquid type of bituminous material we can pour this into this picnometer and cool it down for this to settle down in its cool shape or solid form. and then we can take the weight in the 25 degrees centigrade. But before that we need to raise the temperature of this particular bituminous materials. But while increasing temperature, we need to also remember that we cannot raise the temperature as much as we can expect, or if we whatever we desire. You cannot raise the temperature like that. You can only raise the temperature below 50 degrees centigrade, not more than 56 degrees centigrade. You cannot raise the temperature beyond that, or 100 degree Fahrenheit, whatever I say. Just because of what? If just because this is the expected not more than 56 degrees, sorry, I have just misinterpreted this thing, not more than 56 degree above the expected softening point of the tar. That there is another term that is called the softening point. Bituminous materials, for all the bituminous material there is another term, another property that is called softening point, and will be maybe we'll be conducting another test like the regarding the softening point. But for the time being, we will be understanding this thing, that there is another property for this bituminous material, that is the softening point of the bituminous material, and that is indicating a temperature range, temperature value actually. So a temperature indication is we are getting from this softening point, and that softening point will be indicating a temperature, and that temperature we need to refer. We should not raise the temperature above 56 degrees centigrade of this particular softening point in case of tar. So if we are conducting this test, as we have said, the bituminous materials we can classify as asphalt or tar. So if it is tar, if it is tar, then we should not raise the temperature above 56 degrees centigrade or 100 degree Fahrenheit above the expected softening point of the tub. Just because of what? We will be getting a designation, this is the softening point. Based on the softening point, this is this softening point tar. Just because we haven't made any an experiment, so that's why we don't know the exact softening point of that particular bituminous material, but there is an expected softening point. We cannot go beyond the 56 degrees centigrade above the expected softening point. That is the guideline from our this particular experiment, or ASTO designation, or ASTM, whatever you say. And in case of, if it is asphalt, we cannot go beyond 111 degrees centigrade or 200 degree Fahrenheit. In case of what? In case of 111, in case of asphalt. And in case of tar, not more than 56 degree of the softening point, and in case of asphalt, not more than 1 degree centigrade of the softening point, above the softening point. We cannot go beyond that while giving heat. So if it is already heated and it is likely to be fluid as we are expecting, then quickly pour that particular material within this pycnometer, or if you are using cylindrical, whatever you using, you will be targeting to fill up with tar in this pycnometer up to 1/3 of its total volume. So if it is the total volume up to this range, we need to fill. So we will be filling up to this one. That is approximately the 3/4 of the total volume of this pycnometer, or if we are using cylinder, based on that volume, 3/4 of the volume. Also in this case, 3/4 of the volume will be filled. So 3/4 it is our target. The total volumes 3/4 portion should be filled up using that particular bituminous material. And after that, what we should do, and again another thing I need to mention, this whenever heating this particular tar or asphalt, whatever we say, so if we are heating this using a flame or hot plate, then we should not heat it more than 30 minutes. not more than 30 minutes. Or if you are using an oven, then you should not exceed 2 hours. It should be less than 2 hours, less than or equals to 2 hours for what? For oven. And if you heat it using flame, not more than 30 minutes. Okay. And always again you need to focus on that, so that any air boil should not be entrapped within this particular pygnometer whenever you are pouring this thing. Just because sometimes in addition to the bitumen also there might be some air bubbles within this semi-solid bituminous material, so we should be keeping focus on that as well. Okay. So if there are you might be getting a question in your exam as well. If I say, what might be the problem if there are air bubbles within the pygnometer? If there are air bubbles not removed from the pygnometer while pouring water, then what will happen? Whether you will be getting specific gravity above the original value or less than above your original value. It might be a true false question for you in your quiz exam. So you need to think the questions like this. The quiz question is not, it is just like common sense. You need to think how quick you can think about this, whether it will give you raised up value or lowered value than the original value of specific gravity if there are air bubbles within the water you used in the to fill up the pygnometer. What will be the problem? Then you need to identify. However, whenever you have filled up this pygnometer with the 3/4 of the volume using the semi-solid bituminous material, then you need to think about what? The temperature of this semi-solid bituminous materials is raised up to a temperature which is not actually the 25 centigrade temperature as we are expecting. So while pouring this, you need to keep focus on this, that no remaining portion should be taking in contact with these surfaces like that while pouring. You need to pour this very cautiously, so that the only portion it should be filled up within this one, not beyond that. If it is beyond that, there will be possibility of entrapped air within the pygnometer, and the result you will be obtaining will not be reliable as according to the specific standard. So please be aware of this while pouring this bituminous material within that. However, whenever we will be pouring this up to 3/4, then what will be our task after that? So you will be allowing, even if there are some you see remaining portions like stick into this surface, there are some suggestions for you how to remove it. I'm not going to discuss it. Whenever you will be conducting experiment, maybe the instructor will be showing all these things to you. Whenever we'll be pouring the after pour up to 3/4 of the volume, we need to getting the temperature 25 degrees centigrade again. So that what we should do for that, what we should do now, the same thing, we need to cool it into ambient temperature. So now again we will be cooling this into ambient temperature, or which will be not less than 40 minutes. So for 40 minutes you will be cooling this down. So from all this thing you can easily understand that this experiment is very time consuming experiment, which you cannot do as fast as you can expect. So very time consuming experiments, and all bituminous experiments are very sensitive and obviously very time consuming in manner. So that's why we need to focus on this very carefully. Just small mistakes in our any steps might make us to conduct this test again, otherwise we will not be getting satisfactory result for us. So after 40 minutes, then we will be again waiting this. Whenever it will be cooled to the temperature, ambient temperature, one might ask that, okay, we are just we have we have kept it in the ambient temperature, but why not in the water bath? You might ask me the question about this. Why not the water bath? Just because water bath, if you we are not using, and we need not to ensure that it must be 25 degrees centigrade the particular this asphalt when poured. We need not to maintain the 25 degree or 15.5 degrees centigrade at instant whenever we have poured it up to 3/4 of the volume. Just because of what? Just because specific gravity is dependent on what? Volume. As you know, specific gravity is related to volume, but we are taking what? We are taking actually the weight, not the volume. So as we are taking weight, so it is not necessary that we need to take the weight in 25 degree or 15.6 degrees centigrade after pouring the semi-solid bituminous material, whether it is asphalt or tar, whatever it is. Just we have cooled it down into ambient temperature and we are taking the weight of this. So even if you take weight in this particular volume, it may be in 30 degrees centigrade. For example, if you take the weight, weight will be all the same even if you keep it in 25 degrees centigrade as well. That's why we said to maintain the ambient temperature for 40 minutes. That will be enough for this particular bitumen, and we will be keeping the original test temperature after we will be pouring the remaining portion with water. Then, but not before that. We not necessarily maintain the temperature to the test temperature as it is, just because we are taking just weight, not the volume, after pouring the this bituminous material. That's why you will be just taking the weight, not necessarily we need to maintain the test temperature for taking the weight of this. So weight will be taken, not the volume will be taken. So weight, the taken volume will be again 1 milligram precision, will be taking it, and this new volume, as we have said, where this one, so this one we will denote it as C. This will be the C, as you can see, that is partially filled with what? Semi-solid bituminous material, C. And then the remaining portion, so we need to again draw this, I think redraw this. Let's redraw this pygnometer. So as this is already, I think, filled up to if I say this one up to this one, it is already filled up 3/4. So 3/4 of the pygnometer is already filled up. Then the remaining one, so as this is the volume only, so whenever we will be again we'll be again pouring water within that. The remaining portion will be filled up with water, and then we will be again I forgot to mention about using stopper in this case as well. The stopper we need to use whenever you are using pygnometer. You need to take this. Unless you use this stopper, you will not getting proper weight. See, just because the empty pygnometer was weighted along with this stopper, so always use stopper. So again we will be using stopper, and any entrapped air, if it is there, that will be going outside from this while maintaining this. Again, now in this case, whenever we'll be pouring water, distilled water, in the remaining portion, so it will be approximately 1/4 of the water, whatever it is, and this is 3/4 of the volume, and this is 1/4 of the volume that is filled up with water. Then we will be taking it to the water bath again, the water bath where the temperature is kept at the desired level, so that the temperature up to test temperature either 25 degrees centigrade and 15.6 degrees centigrade will be maintained, just because now we are concerned about the volume, so that the actual volume, this volume is filled up along with water with the semi-solid bituminous material. So not necessarily this is actually 3/4 and this is 1/4. The total, this 100% volume must be maintained. That is our concern, and in this case we need our volume. That's why we need to keep this in the water bath. So again you will be keeping it in the water bath not less than 30 minutes, so that this will be taking the test temperature, and after that the similar procedure will be using any extra volume of water that will be entrapped through the hole, and finally you need to give the stroke and dry all the surfaces, one stroke within the top of the surface, and required stroke with the towel in the outer surfaces as needed after removing it from the water. Then you will be taking the weight again. If you take a weight, this weight, particular weight you are taking, that will be designated as T, and that indicates picnometer plus partially filled water and partially filled, you know what that is, the partially filled of semi-solid bituminous material. So this is T. So all these four, if you once you get this thing, then you will be getting the formula from specific gravity as, if I write it down, the formula for the determination of specific gravity of this semi-solid bituminous material will be Sg will be equals to C minus A divided by B minus A minus D minus C, and this will be the formula for determination of specific gravity for that particular material. Okay, so there might be different questions might arise, that why we are using 3/4 of the volume. I'm just giving focus on this question. You might ask, why 3/4 of the volume should be filled up with semi-solid bituminous material, not less than that? Why 3/4? Can you explain why this is? Is there any question like this regarding why 3/4, not less than that? Why we are not taking just only 1/4 or less than half? So there is a question, there is a problem regarding this. If you are using, so as this bituminous material will be cooled down whenever we are applying water in this, so if the water weight, as you know that if the water weight, we don't know the specific gravity of this semi-solid bituminous material, whether it will be greater than 1 or not, we don't know. So if it is greater than 1, then that is, well, that is fine. So that is heavier than the water, so water will be always above the semi-solid bituminous material. But if I ask you, there might be possibility of some water to be going underneath and the semi-solid bituminous material will be going above the water. There might be possibility if the semi-solid bituminous materials is this material is less heavier or lighter than the original water weight, so the specific gravity is less than 1. This is also possible, you know. So if the specific gravity is less than 1, what is possibility is there? The water might be going underneath it and this will be floating in the water. There is a possibility, and that will give you or hampering you for the actual test result you want to get it. So as there are possibilities, and most likely you will be also getting the specific gravity of this particular material which will be less than 1. There is a possibility you might be getting, or always it will be close to 1 at least, if I can say. So to remove any adverse effect of this, we are taking less amount of water, so that water will be always going above and not trying to penetrate beneath this sample and making any harm or give us mislead to any other values from the original value of specific gravity. So this is the main reason. There might be other reasons as well. So according to my concern, that's why we are using 3/4, not more than half of the, not more than half of the, not less than half of the original volume. Keeping a safe margin, we are assuming at least 3/4, so that it will not create any problem. So there, that is an aspect we can say for this particular, and other reasons might be there which Astro better can explain you. I'm not going to discuss all of these things. If we want to discuss, we can just discuss about one topic for the whole course. That is not possible for us. However, if you have any further question, I can give you answer afterwards, but now I need to finish the lecture off. If this is the specific gravity of the this bituminous material, the formula is there, and ABCD, you know the ABCD, what does what all these things mean. I need not to mention all this again, and you will be getting a value of specific gravity, and you need to round it up to what? Whenever you will be rounding it, you will be reporting SG to the nearest third decimal. And if you will be writing like, okay, specific gravity 0.997, so up to third decimal, this is specific gravity, unitless, at 25/25 degrees centigrade, or in bracket you will be writing 77/77 degree Fahrenheit, or vice versa if you are using 15.6 degrees centigrade. That's why how you will need to report the value of this experiment. So I'm not going to lengthen this lecture as well, lecture further. So just need to say something. There are some other specifications, like if you are testing two simultaneous tests using the same laboratory, then two test results for the same sample should not vary. Up to some limits are there for each type of the semi-solid bituminous materials according to ASTO. So same specific gravity, it should not vary the value. There is a range for tar, for asphalt, for all other things. You might need to, as much you will be conducting this thing or using these things regularly, you will be able to learn, I think, the most important things whatever we have already discussed. Now I will be giving you a question assignment like this, how to derive this specific gravity. In the last class we have derived an equation, how we have obtained the value of angularity number. We have derived the formula. Can you derive this formula as well? If I ask you, can you derive this formula as well for this particular experiment? Well, okay, in very short, I am just giving you the basic explanation how we can be obtaining this formula of specific gravity. So the formula, specific gravity formula, will be what? The some volume, sorry, specific volume, specific volume bitumen weight, and same volume water weight. So with respect to water weight, the same volume of water weight and same volume bitumen weight, this ratio is known as specific gravity, as you know. So from our calculation, the formula was specific gravity is equals to C minus A. What is C and what is A? C, if you just draw the picture like this again, this is A, empty, obviously including the stopper. This is B, totally filled up with water including stopper. This is C, along with the stopper there is 1/3 filled with bitumen. Okay, and again D is what is D? D is the same thing, additionally filled up with, the stopper is there, and D is, if this 1/3 is filled up with bitumen, then the remaining portion will be filled up with water. So that is D. So whenever we are taking C minus A, we are actually getting what? And remember one thing, this is full volume, 1 volume of water. This is 3/4 volume of bitumen, we know, and this is 3/4 bitumen and 1/4 of water, and this is 3/4 of bitumen, as you know. So C minus A indicates what? Picnometer will be deduced, so only the remaining is 3/4 volume of bitumen. So in above, this will indicate 3/4 volume of bitumen, and that's weight is called in the above. So according to the definition of specific gravity, we need what? 3/4 volume, the equal volume. So this 3/4 is only we are using as a reference, just not necessarily 3/4, but whatever the 3/4, if it is 3/4, not 3/4 less than that, with respect to this is also 3/4 or less than that, the same volume, and the remaining will be this one minus this will, the 3/4 will, or any other thing will be giving the value of this one. So we are assuming 3/4 and this is 1/4. Any change will mutually rectify this thing. So in this case, the same 3/4 volume of water weight will be underneath this to give you the specific gravity. So we need 3/4 volume of water weight in there. So what we have here, we have, according to the formula, we have B minus A minus D minus C. So B minus A minus D minus C. Okay, so what is B and what is A? We know from B minus A what we'll be getting. So B minus A, so picnometer will be cancelled out, only the full volume of water will be getting. So I can say 1 volume of water weight. This is B minus A. And what is D minus C? If you see here, it is D, it is C. In this both case, you will be getting picnometer weight cancelled out, and also if it is 3/4 bitumen, also their 3/4 bitumen will be cancelled out, just because of what? Maybe whenever we are taking weight of this volume, it might be increased or decreased than the original, but as we have said, we are just concerned about the weight at that particular time, just because whenever we have pulled it to 25, the same weight bitumen have come to original volume again, come back to the original volume of bitumen as well. But we are concerned about what? The weight. If it were cooled to 25 degrees centigrade or this temperature, the same weight we would have got. That's why the temperature was not a matter of concern in that case particular, whenever we are taking the measurement of C. However, I think I need not to clarify this thing further. However, focus on this. D is the what? D will be including picnometer, C will be cancelled out. Also the 3/4 volume of bitumen and 3/4 volume of bitumen here will be cancelled out. Only remaining will be this yellow portion, the 1/4 of water. So D minus C will give you 1/4 volume of water weight. Okay, and from there the 100% volume and 1/4 of the volume, if it is subtracted, then you will be getting 3/4 volume of water's weight. So as we have said, this is the 3/4 volume of water weight, which will in turn give you the same volume of bituminous weight and the same volume of water weight. This ratio we know this as specific gravity. So I'm not trying to make it further lengthy this lecture, so I need to finish it off. I think all these things you have understood this well. So even if you have any further question, if you ask me, I will be giving you answer. So I hope you have enjoyed this video. Thank you everyone, hope to see you again. Thank you.